Thank you for joining me for this video. In this video, I'm going to talk about how to write robust tests. What do I mean by a robust test? Robust tests fail only when there's a defect. And robust tests do not need to change every time the code that it's testing changes. How do we achieve a robust test? We test what the code is supposed to do, not what it does. Another way to say that is that we assert the bare minimum to ensure correct behavior. I'm going to show you an example of that right now. On the left, we have a function that we're going to test, and on the right, we have the test for that object. I'm hiding the test so that we can focus on understanding the function on the left first. We're going to be iterating on this function and changing it and see how those changes affect the test on the right. So let's take a look at the function on the left. This is a function that saves a user's preferences. It is given an object store that is used to store objects in a database. Here you can see that we call store objects in order to store our first and second preferences object. And then we calculate our third one. This is maybe some work we have to do in order to build the data that we're going to store in the database. And then we go ahead and store that third object. Now on the right, I'm going to show you this test, but first know that this is not a robust test I'm going to show you. This is a brittle test that breaks easily. We're going to start with the brittle test and then show that when we make improvements to the function on the left, that this brittle test breaks easily. Then as we iterate on the function on the left, we're going to change the function on the right to be updated to match. But then we're also going to take a look at how could we write the test the first time around so that when we change the code on the left, the test doesn't need to change. All right, so let's start with looking at the brittle test. Here is where we're calling the function that we're testing. We're passing it a mock object store. And then we continue to assert that the object store is used in a specific way. We assert that the object store was called twice, that the first time it was called with these two objects. The second time it was called with a third preference object. We can run this test and you can see that it passes. Let's say on the left, we realize that we want to call store objects as few times as possible in order to get better performance. Let's say we're going to take the calculation of this third preference, we're going to move it to the top of the file, and then we're going to combine these two calls to store objects. Now, this ends up doing exactly what the code before does, but it does it in a more performant way. So the outcome is identical. The behavior is identical, that's at least seen externally, except now it's more performant. But now the trouble is that this test fails. Let's run this test, and we can see that we expected this function to be called 2 times, but it was only called once. Well, this is an example of the test being brittle. The test broke, even though the function it's testing is behaving correctly. So first, let's go ahead and change this test in a way so that it passes, but it's still going to be brittle. This is something that I see very often people doing, where they'll say, okay, well now it's only called once, and now it's called with these 3 parameters. Now we can run this test and it passes. But let's take a look at how we could have written this test in the first place so that we didn't have to change it when we made the performance improvement. So first, let's undo the performance improvement. And then now let's figure out how we're going to write this test so that it's not brittle. Now it turns out that we don't really care how many times the object store was invoked. Rather, what we actually care about is just which objects were stored. We can get the list of objects that were stored across all calls with the following code. Here I have the mock function, and this code goes through each call, grabs the list of objects that were the mock was told to store, and then flat map concatenates all of those list of objects into a single array. So here I'm saying I expect the object stored to equal these three objects. Let's go ahead and run this test and we can see that it passes. There we go. Now let's do our performance improvement. Again, we're going to move the calculation of preferences 3 up. We're going to combine the two calls to store objects. And now when I run the test, it still passes. So this is an example of a test that's more robust than the previous in that it doesn't assume how many calls to the object store were made. Rather, it just checks which objects are stored. But this isn't actually the most robust test that we can make because it actually does assume the order in which those objects were stored. Another performance optimization might be to change the order in which these objects are stored. So perhaps I move preferences 3 up to the beginning. And now if I run this test fails. But this is still correct code. So how can we write this test so that as I make this performance improvement, this test doesn't need to change? So here again, we're still concatenating all the list of objects into one list. But here we're changing what we're asserting about this array. Before we said it was equal to this array, and here instead we're saying that this array matches an array that contains these three elements. Now we also have to add this assertion that the array is of length 3 because this assertion only tests that it has these three, not that it has only these three. There might be a fourth or a fifth, and this assertion still passes, which is why we need to add this assertion here. So now let's run this test. And this test passes. Even though I said it's an array containing 1, 2, 3, and the array is 3, 1, 2, turns out that this still matches because, again, we're just asserting that it contains these three, not in this specific order. This is the final form of the test. This is robust because, 1, we don't assume how many times the object store was invoked, and 2, we don't assume the order in which the objects are stored. So now on the left, I can change this so maybe in the future 3 calls to the object store will be better. Maybe the order changing will have better performance. Now we have a test that asserts the bare minimum it needs to assert in order to ensure that the function that we're testing has correct behavior. Let's come back to the slides and review. We write robust tests by testing what code is supposed to do, not what it does. And we do that by asserting the bare minimum in order to ensure correct behavior. In our example, we removed the assumption of how many times the object store is called. We removed the assumption that of the order in which the objects are stored. And what we were left with was just asserting that the 3 objects we expected to be stored were stored. So by making as few assumptions as possible, we've written a more robust test. Thanks for joining me, and I will see you in the next one.